Welcome to section 3.3, graphs of the tangent, cotangent, secant, and cosecant functions. At the end of this section, you should be able to answer these questions. How are these graphs related to the sine and cosine functions? Why do these graphs have asymptotes? And where are the asymptotes? Let's start with the graph of the tangent of x. By our magic word SOHCAHTOA, we have these three relationships where the sine of x is the opposite of the hypotenuse, the tangent of x is the opposite over adjacent, and the cosine of x is the adjacent over the hypotenuse. If I make a ratio of the sine of x over the cosine of x, we see that that becomes the opposite of the hypotenuse over the adjacent over the hypotenuse. If I want to simplify the expression on the right, I remember that dividing by a fraction is the same as multiplying by its reciprocal. So now my relationship is the opposite over hypotenuse times the hypotenuse over the adjacent. If I cancel out my hypotenuse, I'm left with opposite over adjacent, which is my relationship for tangent. So I can say that the tangent of x is the same as the sine of x divided by the cosine of x for any value of x. Now that we know the relationship between the tangent, the sine, and the cosine, we can use this relationship to examine the behavior of the tangent of x and plot its graph. I've graphed here the sine and cosine of x, where the sine of x is green and the cosine of x is blue. If we take certain values of x and determine their values for sine and cosine, we can then determine the tangent values. So let's start when x equals 0. When x equals 0, we know that the sine of 0 is 0 and the cosine of 0 is 1. So my ratio turns out to be 0. So from the 0 at sine and the 1 at cosine, we end up with 0 over 1, which gives me a tangent value of 0. Let's look at 45 degrees. At 45 degrees, we can see that the cosine and sine are equal to each other. The sine of 45 and the cosine of 45 are equal to 1 over the square root of 2. That ratio gives me a 1. So at 45 degrees, my tangent value is a value of 1. At 90 degrees, what we see is that the cosine has a value of 0 and the sine has a value of 1. So if I try and create that ratio, the sine of 90 equals 1 and the cosine of 90 equals 0. That ratio, since we're trying to divide by 0, is undefined. Which means in that case I have no value for the tangent, and we have a vertical asymptote there. So I'm going to put that vertical asymptote into my graph. If I move to the left of the y-axis, I can see the same sorts of relationships, and I can plot what's going on there using the appropriate sine and cosine values. At negative 45 degrees, we see that the cosine is a positive 1 over the square root of 2. And at negative 45, we see that the sine is a negative 1 over the square root of 2. So when I create that ratio, we'll see that the tangent has a value of negative 1. At negative 90, we have the same problem we had at positive 90. Our cosine value is 0, and our sine value is negative 1. But again, sine over cosine, negative 1 over 0. undefined, which means we need another asymptote there. So whenever the cosine is equal to 0, we're going to have asymptotes. If I look at the behavior of those red dots and think about what's going to happen between 45 and 90 degrees, what I see is a ratio where the sine function here compared to the cosine function becomes a ratio where a larger and larger number is getting divided by a smaller and smaller number, which would imply that those red dots will begin to rise, and on the left side of the y-axis will continue to fall. And we end up with a graph that looks like this. We can see how that red graph repeats itself every 180 degrees. The first image is shown between negative 90 for our asymptote and positive 90. We see an image, and that red image then repeats itself. If I hide the sine and the cosine, now we can see the repetitive behavior, periodic behavior of the tangent graph.